A very good morning, my dear students. I hope everybody is doing great. In the last class, we had discussed a concept called projectile motion, right? In the last class, we had discussed a topic called projectile motion. So the chapter we are continuing is motion in a plane. All right. Let's see the projectile motion quick recap. Imagine there is a body which is thrown in this way. So this is the y-axis and clearly mentioning it. This is x-axis. Now you can see this is the origin. So there is a body which is thrown with an initial velocity u. We know this is theta and this is horizontal component of velocity ux, and there is a vertical component of velocity here, so that is uy, right? So I'm writing in detail what is ux here, which is u cos theta, okay, which is horizontal component of initial velocity, and uy is equal to u sine theta, vertical component of initial velocity, and I can write the initial velocity u bar is equal to u cos theta into I cap, yes or no, plus u sine theta into j cap according to vectors notation. Okay, see, u cos theta into I cap, u sine theta into j cap. This is initial velocity. Now, so the particle is moving in this way. So let us concentrate on at this position, right? We are just doing a quick recap, my dear students. At this position, x comma y, at some instant t. So what is the coordinates of the body? So this is x. All right. So this is x from here to here. Horizontally, it is traveled a distance x at an instant t. At an instant t. Horizontally, the body has traveled. Horizontally, the body has traveled a distance x. Yes or no? A distance x. So at the same instant, vertically, the body has traveled a distance y. Will you agree with this? Look at this. The point is what? X comma y, right? So vertically, it is traveled a distance y. And here itself I'll write. And vertically, and vertically it is traveled a distance y. No confusion. Now, so from this concept only, we have proved the equation of a projectile y is equal to ax minus bx square. So what is this? What is this? Y is equal to ax minus bx square, right? So this is the equation of the projectile we have got. So what is A and B? Let me write here once again. So y is equal to A is tan theta into x minus B is g by 2u square cos square theta into x square. So this is equation of equation of a projectile once again, and this is in the form of, carefully see, so this is in the form of equation of a parabola. Okay, so what was the final conclusion we have done here? Carefully see, the final conclusion we have made: path of a projectile is parabola. What is that? Path of a projectile is a parabola. A very important long answer type question for your first PUC theory exam. Okay. So this is not the derivation. Derivation we have done in the last class. Right. Now, look at here. There are few important parameters we are going to discuss in this projectile motion. There are few important parameters we are going to discuss, right? So few important parameters in the projectile motion, right? What are those? Number one, right? First one. First one is about time of flight. What is this? Time of flight. Denoted with the symbol capital T. And the second thing is about range of a projectile, denoted with the symbol capital R. And number three is maximum height of a projectile. And the maximum height of a projectile is denoted with the symbol HN. Right? How simple it is. With a simple and a single diagram, we are going to do that. The simple, this diagram. First, what is time of flight? And before moving to that, so particle is projected from here and it is moving, keep on in this way. And at this point, what happens? See, already what we discussed, at any instant you take, see here also you take initial velocity along x-axis is always same throughout the journey. At any instant you take, ux remains constant. Okay, at any instant, imagine from here also you can see, so ux value remains same. Okay, and here, even here, so that is ux and this is uy. Okay, at any instant you take, at any instant, so this is uy. So uy is always changing because it is under the influence of gravity. Again, I am writing uy is changing because it is under the influence of gravity, right? Because vertically the gravitational force is acting on the body. So whereas u cos theta, whereas ux, which is equal to u cos theta, is constant throughout the motion, constant throughout the projectile motion, my dear students. Very, very, very important objective question is u cos theta is throughout the motion, it's constant. Okay, let's come back to our topic. All right, let's come back to our topic here. So what happens? From here it is moving in this way. Ux is constant, and uy value is decreasing. Okay, initially this is uy, so now this is uy. So at this instant this is uy, at this instant this is uy, and at this instant uy is equal to 0. Carefully see, uy in the sense it is vy. Okay, at this instant vy is 0. So at this instant ux is constant only, which is u cos theta. Carefully see, at the point where the velocity is becoming 0. Velocity becomes 0 means only vertical component of velocity will become 0. So that is the point called the maximum height, my dear students. Okay, at what point vertical component of velocity is becoming 0, so that height is called maximum height. Okay, and let me compare this with your previous topic called there is ground. We have just projected a particle upwards. Look at here, there is a particle which is projected upwards with a velocity v. What happens? The velocity is keep on decreases and finally becomes 0. And this is the height from the ground where the maximum height, where the velocity is becoming 0. So that is called the maximum height, isn't it? Isn't it? So the same thing goes here. So here, this is the point where the velocity is becoming 0. Here also, this is the point where vertical component of velocity is becoming 0. Because there is no possibility of becoming a horizontal component of velocity is 0. No point. Okay. So this is the height called maximum height. And time taken by the particle starting from the origin to the maximum height, that is called time of ascent. From the maximum height to the ground, that's called time of descent. So the total time of flight is equal to time of ascent plus time of descent, my dear students. Time of ascent plus time of descent. Now, maximum height, what exactly the maximum height you know? So what is time of flight you know? And range. So range is the maximum horizontal distance traveled by the body. What is the maximum horizontal distance traveled by the body? When a particle is at this instant, so the horizontal distance traveled is only x. When the particle is at distance, horizontal distance is traveled from here to here. When the particle is at here, so that is called the maximum horizontal distance traveled by the body. Yes or no? So this is only the maximum horizontal distance traveled by the body. That's called range. Okay. So this is the maximum horizontal distance traveled by the body. That is called range. Fine. So now we are going to derive an expressions for time of flight, range, and maximum height. Are you ready now? Are you ready now? Okay, I'm just removing this because we don't want this. Okay. So let's find an expression for the time of flight, my dear students. Time of flight. Time of flight is denoted with the symbol capital T. And before moving to the time of flight, so let us take time of ascent concept. Time of ascent means horizontal motion or vertical motion here. So vertical motion. So mostly we need to concentrate on vertical motion. See, the particle is flying from here to here. Okay. So there is initial velocity and there is a final velocity here. You can see there is an initial velocity and there is a final velocity. So I'm just concentrating on, so let us concentrating on vertical motion of the body. Okay, so if I concentrate on the vertical motion of the body, so what I get? So let us use the equation of motion. V is equal to u plus at. So motion in a plane, how the equations of motion to be used, I have given you the clear idea. So I'm just concentrating on the vertical motion. This equation of motion can be written as Vy is equal to Uy minus G into T. What is this T? I am talking about from here to here till the maximum height. Okay. So vertical motion till the maximum height, till H maximum. No confusions. So when I concentrate from here to here, so this is time of ascent. Yes or no? Time taken by this particle to reach the maximum height. That's called the time of ascent. So now Vy, let's substitute everything. Vy is the u sine theta. Sorry. So what happened to Vy? Vy, that means final velocity of the body. So we are talking about initial point is 0, initial point is 0 to maximum height. So initial point is 0, maximum point is maximum height is the final point. See, at the maximum height, what is the final velocity? It is 0. Okay, is equal to uy. What is initial velocity along y component? So this is uy. Uy is what? So it is u sine theta minus g into time of ascent. From here I can write time of ascent is equal to u sine theta divided by g, that is time of ascent. Very important derivation, my dear students. Time of ascent is done. So time of ascent is done. So but we need the time of flight. So how much time it took from 0 to maximum height, the same amount of time the particle will take from maximum height to the ground again. So imagine if your time of ascent is 5 seconds, definitely time of descent also will be 5 seconds. So this I can also write it as time of descent. Okay, so time of descent. So totally time of flight I can write it as time of ascent is u sine theta by g plus time of descent, that is also u sine theta by g. So then the total time of flight is 2u sine theta divided by g. Okay, so what is the total time of flight here? What is the total time of flight formula? 2u sine theta by g. Okay. Clear? So depends on the theta value, it will vary. Depends on the theta value, it will vary. So here what I would like to tell you is the same concept. Let us compare this with the just vertically thrown body. So there is a body which is thrown vertically with the initial velocity v. So time of ascent is u by g. Time of descent also u by g, my dear students. What is the total time of flight? So total time of flight is 2u by g in this case, because body is vertically thrown up. Vertically thrown up means what is the angle made by the initial velocity with the ground? What is the angle made by the initial velocity with the ground? It is 90 degrees. So let us substitute your 90 degree here. So it is 2u into sine 90 is 1 by g. Okay. Understand? Clear? So this is the same expression. This is the same expression. So when theta value is changing, so this time of flight value also changing. Okay. So remember the time of flight expression. We'll solve the numericals of related to this just a little later. So the time of flight is done. Now range. Let's concentrate on the range. So what is the range topic here? Range. Range is denoted with maximum horizontal distance. I'm writing as range is what? The maximum horizontal distance. Distance is equal to speed into time. Distance is equal to speed into time. So range is equal to speed into time. So what is the speed? So when we are talking about maximum horizontal distance, we need to concentrate on horizontal motion. Yes or no? So we are concentrating on horizontal motion, because the definition of the range is telling us maximum horizontal distance traveled by the body. So range is equal to speed into time. What is speed? Horizontal speed. What is the horizontal speed? Throughout the motion, horizontal speed is constant. That is u cos theta. No other confusions. U cos theta is the maximum horizontal speed at any instant, right? Into time. What is time? So to cover this maximum horizontal distance from here to here, what is the time taken? Time taken is equal to time of flight, my dear students. So then R is equal to u cos theta into what is the time of flight? It is 2u sine theta divided by g. So this expression I can write it as u square into 2 sine theta cos theta divided by g. So finally, range of a projectile I could write, range of a projectile I could write u square sine 2 theta divided by g. So what is the range of a projectile we have got? And you must remember the expressions whatever we are discussing. That will be very useful for the numerical solving. So time of flight is 2u sine theta by g, and range is u square sine 2 theta by g. U square sine 2 theta by g. So sine 2 theta is what? 2 sine theta into cos theta. Okay, clear? Now when the sine value is maximum, the range will be maximum because initial velocity is u and this is g is constant. So sine value is maximum, so then range will be maximum. Sine value will be maximum where when sine of some angle is equal to 1. That is the sine. Sine values always oscillate from 0 to 1. Understand? So sine value is maximum, which is 1. So sine 2 theta is 1. So definitely the 2 theta value is equal to 90 degrees. So when you keep 90 degrees here, then only you get maximum. So then theta is equal to what? 45 degrees. Carefully see. So this is the maximum. Okay. So now what I just wanted to tell you is range of a projectile is maximum. So when the theta is 45 degrees. When theta is what? 45 degrees. Carefully see. When theta is 45 degrees, we get the maximum range, right? So when theta is back 45 degrees, what is the range here? So sine 2 theta is sine 90, which is 1. That is just u square by g. Okay. So what is that? Just u square by g. So that is the maximum range formula. All right. Clear? Now, here itself, let us give me a very, very important expression here. I'm just taking let me give you an important expression. Imagine my theta value is carefully 30 degrees. What is the range? Carefully. Range is equal to u square sine 2 theta. Sine 2 theta is what? Sine 60. Sine 60 is what? Root 3 by 2g. That is the range. Clear? So now the theta value I am taking it as this is theta 1. Theta 2 value is I am taking it as 90 minus. So this is theta 2 value I am taking as 90 degrees minus 30. Carefully see. 90 degrees minus 30. Okay. Now, R is equal to u square sine 2 into 90 minus 30, which is divided by 2g. R is equal to u square into sine, sorry, just a second. Sine 2 into 90 minus 30, I can write it as sine 180 minus 60. All right, sine 180 minus 60. It's 2g. So R is equal to u square into sine 180 minus 60 is cos 60. Sine 180 minus 60 is cos 60. So R is equal to u square by, it is not 2g, it's g only here. What is the formula here? U square sine 2 theta by g. So u square sine 2 theta by g. So here 1 is sine 2 into 90 is 180, 2 into 30 is 60. Okay. So this is also 2 is not here. U square cosine 180 minus 60 is cos 60 by g. U square by g into cos 60 is same, root 3 by 2. So range is equal to u square into root 3 by 2g. What you should understand here. See why I have told you these are the few important areas you need to consider. So this is the best example I have given you to prove when your theta value is 30, you got the same range. When your theta value is 90 minus 30, also you got the same range. Carefully see. That means for theta and 90 minus theta, you get the range is same. So that is the conclusion I just wanted to give you. I'll give you a diagrammatic representation also related to this. No confusions at all. Okay, what I wanted to tell you is your initial angle is theta, you got one range. If your angle is 90 minus theta, 90 minus theta is here. If initial angle is 30, you got one range. If your angle is 90 minus 30, that means 60, you get the same range. But the maximum range you get is only at 45. Okay, so I'll show you with the diagram so that you will understand it very, very, very well. So simple. This is x-axis and it's y-axis here. You can see. Imagine I've just thrown the body with, carefully see, with the angle called 30 degrees. How simple it is. See, 30 degrees, one range is there. When my theta is 30 degrees, range is equal to, just now we have solved, u square into root 3 divided by 2g. Because sin 30, sin 60 is root 3 by 2, right? And cos 30 is root 3 by 2. Root 3 by 2. Just a second. Really sorry, here cos 60 is 1 by 2, right? Sine 180 minus 60, sine 180 minus 60, sine 180 minus 60 is sine 60 only. Sine 180 minus 60 is sine 60 only. Okay. Sorry, I'm really sorry about this. Sine 180 minus 60 is sine 60. Sine 60 is again root 3 by 2 into u square. See here, for 30 degrees we got u square into root 3 by 2g, and sine 30 degrees you got this value, 90 minus 30 degrees. That means 60 degrees also you get the same value, u square root 3 by 2g. So when your theta is 90 minus 30, 90 minus 30, you get the same range, u square root of 3 by 2. And you get theta value which is maximum 45 degrees. Theta value is 45 and the range you get is maximum. So u square by g, right? So because range is equal to u square sine 2 theta by g, understand? So that is sine 2 theta is 1 in this case. Now this is 30. Look at here. When I project this with 90 minus 30, 90 minus 30. So this is the angle of projection. You can imagine as some 60 degrees. That means 90 minus 30, right? 60. So range is same, you can see. So R1 is equal to R2 because this is my first case and this is the second case. So for 30 degrees you got the same range. For 90 minus 30 degrees also you got the same range. Now I'm just projecting with 45 degrees. So 45 degrees, it will definitely be between 30 and 60. See, for 45 degrees, I have got the maximum range, my dear students. So this is my angle here. In third case, the angle is a 45 degree, and that is the maximum range I have got, which is maximum. Okay. So this is what you should understand from this case, right? I hope there's no confusion till now. All right. So now we are concentrating on an expression called a maximum height. What is that? A maximum height. As its name indicates, maximum height, we need to concentrate on vertical motion. We need to concentrate on vertical motion. To derive this maximum height, so let me draw the brief, once again, a simple projectile motion picture. Simple. Because without going back, we can do it here itself. So this is the maximum height. At maximum height, what is that? Vy is 0, and this is the direction of ux, which is equal to u cos theta. Time taken to reach the maximum height is time of ascent. So at maximum height, imagine, so this is the distance x traveled. Imagine at maximum heights, the coordinates are x comma y. So this is x distance traveled, and this is my y distance traveled. So y is equal to maximum height. Yes or no? See here, vertical axis along y axis, this is the maximum height. This is the maximum height. Okay, so y is equal to h maximum. Okay, now, so time of ascent, you know the time of ascent expression. So time of ascent expression is equal to u sine theta divided by g. Okay, now, so we are concentrating on vertical motion of a body. We are concentrating the vertical motion of a body. So we can use the formula called the S is equal to ut plus half at square. So in the motion in a plane, you can write S is the vertical displacement we need, y, right, which is equal to, so vertical velocity minus half g into what is the time taken to move from here to the vertical displacement. So that is time of ascent square. Okay. So now I hope it is very easy for you, and let me start. What is that? Y is the maximum height, which is equal to uy is u sine theta into, so this t is also time of ascent. Okay, so time of ascent is u sine theta divided by g. Okay, minus half into, so g into time of ascent square, which is u square sine square theta divided by g square. Okay, because time of ascent formula you have written here, u sine theta by g. So one g cancel here. So this maximum height is equal to u square sine square theta by g minus u square sine square theta by 2g. So here u square sine square theta by g, if you take common, it will be 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. So the maximum height is equal to u square sine square theta divided by 2g, my dear students. U square sine square theta divided by 2g. Okay, so let us discuss the same expression for the vertically projected body. Okay, vertically projected body. So this is the round. If I project this body vertically with some initial velocity u, what happens here? This is the point. Okay. If I project it, the what is the velocity at the maximum height? 0. So that is the maximum height. So we have the formula by using equations of motion. Maximum height is u square by 2g. All right, maximum height is what? U square by 2g. So here theta is what? With the round, initial velocity is making an angle 90 degrees. So 90 degrees, if you substitute, sine square 90 degrees is 1. So then that is u square by 2g. You get the same expression. So there is a similarity between the projectile motion and the vertically thrown body. Just depends on the angle here. So here also, when the angle is changes, the maximum height value also will be changing. Okay, clear? So finally, let me write the expressions for all these time of flight, maximum height, and range of a projectile, right? So that will be the conclusion of this particular session. First, time of flight, it is 2u sine theta divided by g, right? So next we found range. Range is equal to u square sine 2 theta by g, right? Next, maximum height of a projectile is u square sine square theta divided by 2g. Okay, clear? So these are the three important expressions related to the parameters of the projectile motion. Very important, very important. There are so many cases involved in this chapter related to these formulas. We will be doing the numericals also now. So I please remember and write these formulas somewhere, so because they will be useful a lot. All right. Now, so let us have some numericals based on these areas. Let's see this first question. So there is a ball thrown up with a speed at 20 meters per second. It is thrown with a velocity, so with an angle 45 degrees. The question is, by taking your G value is 10 meters per second square, find time of flight and range. That's a question. Simple, right? What is the time of flight expression? Time of flight is equal to 2u sine theta by g. What is 2u sine theta by g? 2 into u sine theta, sine 45 degrees. It's 1 by root 2 divided by g is 10. Okay, that's it. So this is 2 into root 2 into root 2 into 1 by root 2. So I can cancel this. So and I get, so the time of flight is 2 root 2 seconds. That's it. So now range also they are asking you to calculate. So the range is equal to, what is the formula? U square sine 2 theta divided by g. So u square, it's 20 into 20 sine 2 theta, it's sine 90. See, whenever you see this theta is 45, immediately you should recollect that the range you get, which is maximum. Remember this. Maximum range is possible at what angle? 45 degrees. 20 into 20 into sine 90, it is 1 divided by g. G is 10. So here I get range is how much? 40 meter. For any other angle, the range will be lesser than this only. Okay. For any other angle, the range is lesser than this 40 meters. So like this, the numericals also will be asked. So these are the basic things. Okay. Next numerical, let us check. Here, a projectile has a range. So given range is equal to 40 meter and reaches the maximum height. So they have clearly given maximum height it is reached 110 meters. So find the angle at which it is projected. Simple. Given maximum range of a given the range of a projectile and the maximum height. So this is not the maximum. Okay. So this is not the maximum. They have not mentioned anything. This is the maximum. So you need to find the theta. So these are the commonly asked questions, my dear students, and how you can solve them. First, write the range expression. What is the range expression here? So range expression is u square sine 2 theta divided by g. So what is this? It is 40. Let me say it is equation 1. And the maximum height. What is the maximum height expression? U square sine square theta divided by 2g. So what is this? So this is 10. So it is equation number 2. So when these two equations, so you can see, when these two equations, if you divide, what happens? So we can eliminate the g value and you can eliminate the u value also. So let me write equation 1 divided by 2. So right hand side it is 40 by 10. 40 by 10, which is equal to left side u square sine 2 theta by g, right? So all divided by u square sine square theta by 2g. No confusions, right? U square by g, u square by g cancel, right? So in the numerator it is sine 2 theta by 1 into, when the denominator taken to the other side, so it will be 2 by sine square theta. Okay, so here what I can write, 4 by 1 is equal to, what is numerator? 2 into sine 2 theta, 2 sine theta cos theta divided by sine square theta, which is sine theta into sine theta. So here sine theta cancel, and this is 4 into, so this is cos theta by sine theta is cot theta is 1 by tan theta. So what is the final expression I can write, my dear students, here? 4 by 1 is equal to 4 by tan theta. So 4 cancel. So tan theta is equal to 1. When tan theta is equal to 1, theta is equal to 45 degrees. Yes or no? Theta value is how much? 45 degrees. So we got the theta 45. Theta is 45 means range is maximum. So initially we thought that range is not given, which is maximum. But finally we concluded that range is maximum because theta is given as 45. Irrespective of the velocity, theta is 45 means range is maximum. When theta and 90 minus theta are the angle of projections, then the ranges are same. Then the ranges are same. All right. Are you ready to solve one more question for you? One more question. Let's see. A stone is projection. A stone is thrown. Look at this. Let me draw a rough diagram for this question instead of writing everything here. A stone is thrown with a speed of 10 meters per second at an angle of projection 60 degrees. So here, there is an angle of projection 60 degrees and it is thrown up with a velocity 10 meters per second. Find its height above the projection of point when it is at the horizontal distance of 3 meters, right? So imagine the particle is at a horizontal distance of 3 meters. Simple. Imagine the point is at x comma y coordinates. 3 meters is the horizontal distance. So what is the y? So that is the question. Okay, simple. So this is the question. Again, I'm reading a question for you. A stone is thrown with a speed of 10 meters per second at an angle of projection 60 degree. Find its height above the point of projection. This is the point of projection when it is at a horizontal distance of 3 meters, right? So now they have also given take t is equal to 10 meters per second square. Okay. It is so simple, my dear students, here. How it is simple? We know whenever this kind of questions are asked, you can find y and x value, y or x values by using the concept called path of a projectile is parabola. Okay, so let us take the concept called the path of a projectile is parabola. Path of a projectile is what? Parabola. Now, y is equal to ax minus bx square. So this x, we know y values we need to find out. So this is tan theta into x minus g by 2u square cos square theta into x square. So that is y is equal to ax minus bx square. Sorry, ax minus bx square. All right. Y. That is why we need to find out tan theta. So can I write it is tan 60 degrees into x. What is x? It's 3 meters. Okay. Minus g is 10 divided by 2 into u square. What is u square? It's 10 square. Understand? It is 100 into cos square 60 degrees because initial velocity, initial angle is 60 they have mentioned into x square. So this is, what is x square? X square is 3 square. Simple. Everything you have except this y. So now This is your classwork. Just find out the y value and tell me the answer. So your y value is approximately, it will be 3.4 meter. Approximately, you get 3.4 meters, my dear students. All right. So this is how the basics of projectile we'll be discussing, and the next class what we are going to do is the most important applications of projectile motion and NEET or JEE problems, because this is the session is all about deriving the time of flight and learning exactly what is meant by time of flight, horizontal, maximum distance, that's called range, and maximum height. So deriving these expressions and understanding the concept behind those expressions is about this session. Okay, the next session is most important, and which is 100% based on these formulas only. And my suggestion for you is remember these formulas and try to recollect these formulas whenever the possibility is there. Okay, now all the very best for your assignment. Good luck.